Today is similar to what we were doing yesterday, but the questions are going to be worded a little bit differently. Okay, so today we're looking at continuity over an interval. Yesterday we were only looking at single points, so we wanted to know at 2, is this function continuous? So a function is continuous on an interval if the function is continuous at each point in the interval. Basically, if it does not have any discontinuities in that interval, then it is continuous. So it's going to be similar to what we were doing, because to show that something is continuous on an interval, we are just going to look for discontinuities, really. So it's very similar to what we're going to do, we were doing yesterday. The following functions are continuous on all points in its domain. Or maybe the domain would be more grammatically correct to say there. Alright, so following functions are continuous for all points in the domain. Polynomial functions, that's just like, it could be f of x equals x squared plus 3x minus 2. Or it could be g of x equals 3 minus x to the 5th. Basically, you just have x's raised to powers. Okay. Rational functions. So, rational functions are going to be fractional. So, f of x equals x plus 2 over x minus 4. Now, it's continuous everywhere in the domain. So you do still have to know about the domain. Their domain is all real numbers, right? Rational functions. What's the domain for this particular rational function? What value can we not have? We cannot have 4. So the domain for this is everything except x cannot equal 4, right? So this rational function is continuous except at 4, right? So this does not mean these functions are continuous everywhere. They're continuous everywhere in the domain. Okay? Power functions are going to be similar to polynomial, but a little bit different in that it's usually just like a single variable, and it could be raised to really any power. It could be something like x to the 7th, or it could be something like x to the 1/2, right, which is a square root, but that's a type of power function. There. Power functions are going to be, continuous anywhere in the domain. Exponentials, this might be something like f of x equals 10 times 2 to the x power. It might be something like this, 1000 e to the 0.7x, something like that. Logarithmic, it's pretty self-explanatory, but it might be something like log base 7 of x. Could be something like 5 natural log of x plus 2. Those would be logarithmic. And then, of course, your trig includes sine, cosine, tangent, secant, cosecant, all of those there. Again, this does not mean it's continuous at all points, just at all points in its domain. So, we need to consider the domains of these a little bit to refresh our minds what we have to think about for domains. So, polynomials are super easy. Polynomials are always all real numbers. Have I used this symbol with you guys before? The double bar R. It signifies all real numbers It is not something I made up. It is a real mathematical symbol. You may use it, or you may, if you're using interval notation, negative infinity to infinity. For rational equations, rational means fractional, the denominator cannot equal 0. So whatever you've got in your denominator, it cannot equal 0. We've worked a lot with that because that's what we've been looking at primarily for our discontinuities. All right, power functions, something like f of x equals x to the 5th, that is just going to be all real numbers. The times that we are going to run into restrictions on power functions is when we have our fractional exponents. So if I've got something like x to the 1/4, right? That would be the 4th root of x. So in this particular case, whatever is underneath your root, so what is under the root, it must be greater than or equal to 0. But there's another little asterisk for this one. Does that apply if I'm doing something like the cube root of x? Or the 5th root, or the 7th root, or the 8th root? Okay, it's got to be with, I'm going to put an n right here, or where n is an even number. Okay, so when we have roots, if it is an even root, a square root, a 4th root, a 6th root, an 8th root, and so on, then whatever's underneath the function has to be, underneath the root has to be greater than or equal to 0, because we cannot take roots of negative numbers unless it's odd roots. The cube root of -8 equals -2. You can take the cube root of negative numbers there, because -2 to the 3rd would give you -8. So we can take the cube root of negative numbers, or 5th roots, or 7th roots, or so on. Okay. Questions so far? What about exponentials? What are our domains for exponentials? It's all real numbers. Okay. All real numbers for this one. Always, unless you have like really crazy exponentials, because sometimes you could maybe have functions that are like a combination of these two. It's exponential, but it also has a root in its exponent or something like that. So this is speaking for the parent functions, those basic functions. So that would be -infinity to infinity. What about logs? Anybody remember the restrictions on logs? So like if I have f of x equals log of x minus 2. They do have vertical asymptotes. How do I know where that vertical asymptote is going to be? It'll be at 2, because whatever is inside of the log here has to be greater than 0. It cannot equal 0 because you got a vertical asymptote there. It's not actually hitting that line, right? It cannot equal 0, and it cannot be a negative number, right? So what is inside the log has to be greater than 0. For roots, it can equal 0. Square root of 0 is 0. But log of 0 is undefined. And then finally, trig. If I have sine or cosine, what is our domain for sine and cosine? It's all real numbers. So, negative infinity to infinity. So, sine and cosine, they are continuous everywhere. Tangent, cotangent, cosecant, and secant. I'm just going to put that they have restrictions because they're going to have periodic vertical asymptotes there. We're not going to take the time right now to go through every single one of those because it'll take a little while, and it's not going to be our primary focus today either. So just know that those are going to have asymptotes and have restrictions. Okay. So if we see a polynomial, a power function where we don't have a root, an exponential, or sine or cosine, our graph is just continuous everywhere for that. But if we see rationals, roots, or logs, rationals, roots, logs, or any of these restricted trig functions, that's when we know we're going to have issues, right? So, let's look at what the problems will look like for this. Okay? Show that f of x equals 1 over x is continuous on the interval from 2 to infinity. Now, is 1 over x continuous everywhere? No. Okay? Specifically, Grace, where is 1 over x minus 1 discontinuous? 1, right? So, f of x, let me write here. Why does it quit on me? It's just completely quit. I'm going to type it on this one, see what's wrong with this. Alright, so, f of x is continuous everywhere except at x equals 1. Right? Because it is a rational function. We said rational functions are continuous over their whole domain except for at the places where the domain is restricted, right? So it's continuous everywhere except at x equals 1. But does 1 fall on this interval? Okay? So we would say since 1 does not fall on the interval 2 to infinity. Let me copy that. No. Let me copy it, but it put a weird giant space there. So on the interval 2 to infinity, f of x is continuous on this interval here. So really it's a lot different than what we were doing yesterday. You're still finding your discontinuities. Then you're really just checking to see if that discontinuity is on the interval that we are looking at. Okay, questions? All right, so graph of g of x is shown below. The graph is made up of a line segment, a point, and part of a parabola. Is g continuous on the interval from 4 to 8? Why? Okay, so if we're thinking about the interval from 4 to 8, going to put myself some dotted lines here. 4 falls right here. 8 is right here. On that interval, is this function continuous? Yes, because it is just a parabola, right? So we would say g of x is continuous on the interval 4 to 8 because because g of x is a parabola on that part of the graph. And that for some reason, let me just, so, there we go. So, we are continuous here. Now, same graph, is this continuous from -2 to 8? So if I slide this over here to -2. Alright? Is this graph continuous everywhere? No. Okay, so when it is not continuous, this is when I really need my pen to work, and it's not, it takes the battery. Maybe the battery is the problem. I forgot this thing took a battery, and I called them down here from Calc to tell them that it was broken, and I needed a new one, and then they told me to use the battery. There's been more because I called Calc in, and it was unnecessary. Called them down here one day, and I had just, whatever I was trying to do was not plugged in. I did check to see if it was plugged in, but I've got so many cords that I didn't realize it wasn't plugged in. Oh, good, it was just battery. Okay. So, I try to be not like helpless with technology. I'm decent, but sometimes I do really dumb stuff. Alright, so, we are not continuous. Now, if I am answering this question, and it says why, or explain your answer, okay, I've got to tell why it's discontinuous, right? So this is going to be similar to what you did yesterday, alright? So, our issue is at x equals 3, right? So, at x equals 3, does my limit exist? Yes. Limit as x approaches 3 of f of x, what does it equal? -3, I think. Okay? And does f of x exist, or f of 3 exist? It does. What does it equal? Oh, no. So, I got my limit is -3, but f of 3 is 1. So, my issue is that those two do not equal each other, right? So, limit as x approaches 3 of f of x does not equal f of 3. And f of x is not continuous at x equals 3, and thus not continuous on the interval -2 to 8. Oh yes, everything I've done here should say G instead of F. Now, as far as AP exam goes, because here's a good question. Does that matter? What happens if you do that? You know, because the problem clearly says G. We're talking about F. What happens if you do that on the AP exam? Here's the answer. If it is a problem like this, and there is only a G of X, and you call it F of X all the way through the problem, like I just did, they will still give you the credit for that problem. However, if G is used as a variable anywhere else, then you will not get credit for the problem. So if there is a G of X function, or even if G is like used as a variable in another part of that problem or something, then you will not get credit because it will look like you're referring to that instead of, or I'm sorry, if F is referred to, whichever one is, you know, if whatever you're replacing it with is in the problem somewhere else, you're not going to get any credit. So watch out for it. Try to go with what they have used, but it is easy to mix it up. Yes, Raven? You need to go with whatever they gave you in the problem. It changes if the discontinuity is at the endpoints. So, for example, is G of X continuous on 3, 8? I'm not going to answer that long out and explain it. But is it continuous there? Yes. Because that does not include 3. And our discontinuity is at 3. Is G of X continuous on 3, 8 with brackets? That would be a no, because our discontinuity is at that endpoint, and that endpoint is included. So it just depends on whether or not those endpoints are where your discontinuity is at. For this problem, it didn't make a difference for the ones that I had asked you originally. But it could. Yes, Wesley? As long as you have the essential information. So you might do it in a little bit different order. Right. So, yeah. So, as long as you have the essential information. So, to like highlight that, your essential information here for the first one would be that you got to include that it is continuous on that interval. You have to say that at some point. And you have to say it's because G of X is a parabola. Right. So, if you do it in a different order, if you say G of X is a parabola on this interval, therefore G is continuous on this interval. That's fine. Like if you word it a little bit differently, that's okay. In that second one, your essential information is you're going to have to somewhere show that this limit equals -3, this limit, or G of 3 equals 1, and therefore they're not equal to each other. And you must make the conclusion that G is not continuous at X equals 3. If you do that a little bit out of order, or if you say it's not continuous at X equals 3 because of these things, that's fine. And then you must also, because the question didn't ask you about 3, it asked you about that whole interval. Because 3 is in that interval, you got to then answer their question. Say, so it's not continuous on that interval. So those pieces all have to be there. But how you word it and in what order you do those things are don't necessarily have to go in that order. Now you can't make those conclusions like this is not continuous until you, I guess you could say G is not continuous because and then list your reasons. Yeah. Right. Yeah, so that's okay, but it just has to include that information. Yeah. Okay, questions? All right. All right, so we got two functions. We want to know, is f of g of x continuous on the interval from -infinity to infinity? Okay, so to do this, we need to know what f of g is. So f of g of x, we're going to take g of x, we're going to put it right here. Okay, so we got 1 over the square root of x plus 2 minus 5. What? No. Not on this one, because what we really care about is the domain of this one. So you've got actually two problems with your domain here, right? You have the issue that you got an x plus 2 underneath the square root, and then you have like the larger issue of you've got a denominator here, right? So, really all you have to do is show that there's 1 point, at least 1 point on this domain from negative infinity to infinity where this is discontinuous. I think the easiest thing to do there is just like denominator equal to 0, right? So square root of x plus 2 minus 5 equals 0. So if we add 5 to both sides, square root of x plus 2 equals 5. We will square both sides. X plus 2 equals 25. We'll subtract that 2. X equals 23. So at this point, we could make the conclusion that that f of g of x is discontinuous at x equals 23 because f of g of 23 is undefined. All right, because if we plug in 23, it is going to give us a 0 in the denominator, making that undefined. So therefore, f of g of x is not continuous on negative infinity to infinity. This is one way this problem can be done. So I dealt with the denominator equaling 0 here, right? That is not the only thing that would give us a discontinuity for this, right? The other issue is that we got x plus 2 underneath the square root. So it is also true, so this would be, you could stop here. This would be sufficient to answer this question. Because if this function is not continuous on that whole interval, if there's even 1 point where it's not continuous, we can't say it's continuous on that interval, right? So we have shown 1 point where it's not continuous, so we've shown that f of g of x is not continuous on that interval. So this would be enough to answer the question that has been asked. It's not the only way we could do it, though. We could also consider that x plus 2. What do we know about x plus 2 right here? What can I not have under the square root? Negatives, right? It gives me imaginary numbers. So that means x plus 2 has to be greater than or equal to 0. So x must be greater than or equal to negative 2, right? So we could make a conclusion like this. F of g of x is not defined for x is less than negative 2. So whenever x is less than negative 2, we get negatives under the square root. So f of g of x is not continuous on negative infinity to infinity. No, because at 2, it's still defined. Because at 2, you'd have 2 plus 2, which would give you, I'm sorry, at negative 2, you get negative 2 plus 2, which gives you 0, square root of 0, 0, but you still have that minus 5, so you wouldn't get a 0 in the denominator. So it could equal 0, because the square root of 0 is 0. So it can equal 0. So here, it is defined at x is equal to negative 2, but not below that. Okay, so here is like, that's another option for how you could answer this question. If the question was worded differently, just so you see this, if it said, tell the domain for which f of g of x is continuous here, if that was our question, what would our domain be where this is continuous? We know we got to have numbers greater than or equal to negative 2, but what else? And we cannot equal 23. So I would write it like this. We would use a bracket here because it includes negative 2. Negative 2 to 23, parentheses, and then 23 to infinity, like that. Or you could say x is greater than or equal to negative 2. Well, probably the way you need to do it if you do it with inequalities, just do it this way. Negative 2 less than or equal to x less than 23, and x is greater than 23. So there's a couple ways that question could be asked, really asking for that same information. All right. All right, we were supposed to describe the intervals on which this function is continuous. So this is kind of like that last way I worded the question, right? We know where this is continuous, which really what we need to know is where is it not continuous. And then when I know where it's not continuous, I can tell the intervals where it is continuous, right? So we're using this function right here everywhere except at x equals 3. So I need to know what this limit right here is. So I'm going to do the limit as x approaches 3 of, is that all right if I go ahead and factor here, x minus 3, x plus 3 over x minus 3. X minus 3's cancel, and I get 3 plus 3. So what do I get here? 6. So my limit as x approaches 3 is 6. But what is the value of the closed-in circle that's supposed to fill in that dot? It is 3. So does it fill in our open circle up here at 6? It does not. Right? So we are not continuous at 3. So I would need to say f of 3 equals 3. Right? Because if I plug in 3, which is the only time I ever use this bottom function is if I plug in 3, the answer is 3. So we would say since limit as x approaches 3 of f of x equals or does not equal f of 3, f is discontinuous. At x equals 3, but continuous, because that's really what it asked me, the intervals where it's continuous, right? On negative infinity to 3, 3 to infinity. I'm supposed to use the upside down. Okay. Why do I always get that mixed up? I should have that straight. Which one is it? I'm going to have to go look at some problems to make sure I'm doing that right. I may have my union wrong there. I'll go look at some problems and let you guys know. Okay? So, your assignment that you might have time to do before we go, I think comes from AP Classroom again tonight. So, if you will go to AP Classroom and bring up that assignment.